Hello, my name is Dr. Steele, and welcome to Steele Mathematics, where lessons in Algebra 1, Geometry, Algebra 2, Pre-Calculus, and Calculus are taught. And today, we are going to talk about the addition postulates, the segment addition postulate, and the angle addition postulate. But before I get right into it, I want to introduce to you some symbols. Now, as we know, the name of the two endpoints of a line segment with a bar over it means line segment. But if we remove the bars, it means the measure or length of line segment AB. Of course, this symbol means angle GOH, but if we put an M in front of it, that means the measure of angle GOH. Keep in mind that the line segment and the angle are the two basic figures that can be measured. So now that we have an understanding, we can go ahead and talk about the two postulates. First, you have the segment addition postulate. If M is between A and B, then the length of segment AM plus the length of segment AB equals the length of segment AB. So as you can see, segment AM and segment MB make up segment AB. Next, we have the angle addition postulate. If N is inside angle AOB, then the measure of angle AON plus the measure of angle NOB equals the measure of angle AOB. So if you can look at it, angle AON and angle NOB make up angle AOB. Now, these two postulates actually say the same thing. The sum of the parts is the whole. So now, let's look at examples of how to use these postulates. All right, so let's say you ask to find the missing measure. On number 1, you have a line segment that measures 7 and the other measures 12. And it's asking, what is the measure of the whole line segment? By the segment addition postulate, it is 7 plus 12. And 7 plus 12 equal 19. So all you have to do is just add the two parts up and you will get the whole. And it is the same for number 2. One part of it is 25 degrees. The other part of it is 52. So all you got to do is just add up the two measures. And you will get 77 degrees. And that's by the angle addition postulate. And number 3 is another example of the angle addition postulate. One part is 34 degrees and the other part is 20 degrees. So all you got to do is just add them up. And you would get 54 degrees. And number 4, we got a line segment split into one that is 17 and the other is 27. So you just add them up. And this will give you 44. Now, if we look at number 5, now you're given that the whole angle is 110 and one part of it is 35, and you ought to find the other part. Well, if you know the whole, and you know one part of it, then to get the other is to subtract 110 minus 35. And this will give you 75 degrees. Number 6, you're given that the whole line segment is 29 and one part of it is 21, and you ought to find the other part. Well, if you know the whole and one part of it, to find the other part, you just, again, subtract. 29 minus 21 is 8. Number 7, you got the whole, and you got one part, you want to find the other part. Just subtract. 30 minus 11 is 19. And finally, on number 8, again, the whole angle is 73 degrees, and one part of it is 55. So to find the other part, you just subtract. And you get 18 degrees. So as you can see, by the segment and angle addition postulate, if you know the two parts, if you want to find the whole, you add. But if you know the whole and one part of it, then to find the other part, you subtract. Now, let's see what happens when algebra is applied to this. When solving geometry problems using equations, use definitions, postulates, and theorems to set up your equations. So what I'm going to show you next is how to use the segment and angle addition postulate to set up equations. All right, so let's say you are to find the value of x. On number 9, you're given the two parts and the whole. By the angle addition postulate, 13x plus 5 plus 7x plus 2 equal 87. So as you can see, the angle addition was applied to set up the equation. So now that we set up the equation, all we got to do is just solve it. We're going to combine our like terms. 13x plus 7x is 20x. 5 plus 2 is 7. Equal 87. We're going to subtract 7 from both sides, and you'll get 20x equal 80. Divide both sides by 20. You get x equal 80 divided by 20 is 4. So the solution is 4. So number 10, we're going to use the segment addition postulate to set up our equation. So we have 5x plus 2 plus 6x plus 1 equal 36. So now we're going to combine our like terms. 5x plus 6x is 11x, and 2 plus 1 is 3, equal 36. We subtract 3 from both sides, and you have 11x equal 33. Divide both sides by 11, and 33 divided by 11 is 3. So the solution is 3. Number 11, we're going to use the angle addition postulate. We get 3x plus 2 plus 6x minus 1 equal 11x minus 13. So first we're going to combine alike terms. 3x plus 6x is 9x, and 2 plus negative 1 is 1. We're going to subtract 9x from both sides. You'll get 1 equal 11 minus 9x is 2x minus 13. We're going to add 13 to both sides. So you have 14 equal 2x. Finally, we're going to divide both sides by 2. 14 divided by 2 is 7. Bring down your x. Therefore, the solution is 7. So as you can see, we use the segment and angle addition postulates to set up the equations. So now let's look at the last few examples. Suppose that the length of segment AB is 2x plus 1, the length of segment BC is 4x plus 3, and the length of segment AC is 7x minus 1. So we know this is 2x plus 1. This is 4x plus 3. And the whole thing is 7x minus 1. So now they actually define x. So we're going to use the segment addition postulate to set up the equation. We have 2x plus 1 plus 4x plus 3 equal 7x minus 1. We're going to combine our like terms. 2x plus 4x is 6x. 1 plus 3 is 4. Bring down your 7x minus 1. Next, we're going to subtract 6x from both sides. You have 4 equals 7x minus 6x is x minus 1. Then we add 1 to both sides. 4 plus 1 is 5. So therefore, x is 5. Number 13, we are to find the length of segment AB. Now, as you can see in the expression, it's 2x plus 1. But we know that x is 5. So all you got to do is just replace x with 5. 2 times 5 is 10, plus 1 is 11. So the length of segment AB is 11. We know BC is 4x plus 3, but again, x is 5, so we'll replace x with 5. 4 times 5 is 20, plus 3 is 23. Next, to find the length of segment AC, now there are two ways to do it. You could take 7x minus 1 and replace x with 5, or you could do just 11 plus 23. Either way, you're going to get the same thing. Therefore, 11 plus 23 is 34. So the solution is 34. Now again, if you want to take 7x minus 1 and replace with 5, you're still going to get 34 either way. Therefore, the length of segment AC is 34. The segment and angle addition postulates both say that the sum of the parts is the whole. If you know the two parts, all you got to do is add them, you get the whole. And if you know the whole and one of the parts, you subtract to get the other part. And of course, as you saw at the end, both these postulates can be used to set up equations. I hope that you have a wonderful and blessed day.